Fresnel diffraction and Fraunhofer diffraction. Diffraction is the slight bending of light as it travels around the edges of an object or after passing through an opening. When the amount light is bent by depends on the exact wavelength of the light and the size of the aperture. Diffraction can usually be characterized by one of the two types, Fresnel diffraction and Fraunhofer diffraction. Fresnel diffraction or near-field diffraction occurs when a wave passes via a small hole and diffracts, creating a diffraction pattern. The size of the pattern depends on the distance between a projection and an aperture. This type of diffraction occurs when the distance of propagation of diffracted waves is short, resulting in a Fresnel number greater than 1. Diffracted waves become planar when the distance of propagation is increased. Fraunhofer diffraction or far-field diffraction is a type of wave diffraction which occurs when field waves pass via a slit or an aperture, thereby changing the size of an observed aperture image with respect to the increasingly plane nature of diffracted waves and far-field location of observation. Comparison between Fraunhofer diffraction and Fresnel diffraction. First one, surface of calculation. In Fresnel diffraction occurs on a spherical surfaces, Fraunhofer diffraction patterns on flat surfaces. Diffraction pattern. Shape and intensity of diffraction pattern changes as the waves propagate downstream of the scattering source. Shape and intensity remain constant. Moment of diffraction pattern move along the corresponding shift in the object remains in a fixed position. Observation distance is being placed at finite distance from an object. Infinite observation distance. Wavefront, cylindrical wavefront, plane wavefront. Thank you. Nicol prism. It is a calcite crystal whose length is 3 times its breadth or thickness. Its working is based on a phenomenon of double refraction. In double refraction, an incident ray splits into two component rays called as ordinary and extraordinary ray. Ordinary ray obeys ordinary laws of physics and is plane polarized. Extraordinary does not obey ordinary laws of physics. It is also polarized. The two rays are plane polarized in mutual perpendicular planes. Optic axis. It is a direction inside the crystal such that the single ray of light does not split into O ray and E ray as their velocities are equal. Double refraction is not observed along optic axis. Principal plane and principal section. A plane containing the optic axis and perpendicular to the opposite faces of the crystal called principal plane. Section of a crystal along principal plane is called principal section of the crystal. Construction of nicol prism. A calcite crystal of length 3 times its breadth is cut along the proper direction. Its principal section is a parallelogram of 71° and 109° angles. The two pieces are drawn so that the angles of principal section are changed to 68° and 112°. As shown in the figure, the two pieces are joined together along diagonal AD by sticky liquid known as Canada balsam. The side faces are blackened. Working of nicol prism. A ray of light is split into O and E ray, which are both polarized. O ray has vibrations perpendicular to principal section. Refractive index of calcite for O ray is 1.658 and refractive index of banana balsam is 1.55. Thus, for O ray, the calcite crystal is denser medium. It is totally reflected by Canada balsam and absorbed by blackened surfaces. E-ray has vibration in the plane of principal section. Refractive index of the crystal for E-ray is 1.486. Calcite behaves as rarer medium, so it is transmitted by Canada balsam and finally emerges out the crystal as polarized beam of light. Nicol as analyzer. Two nicols N1 and N2 are arranged in the line of incident ray. N1 is polarizer and gives out a plane polarized light. Two nicols are parallel, that is, their diagonals of principal section are parallel. N1 and N2 are crossed. The principal section of N1 and N2 are perpendicular. E-ray becomes O-ray as its vibrations are perpendicular to principal plane of N2. So the ray is totally reflected and absorbed by the side faces. Thus intensity is zero for emerging light. Rotation of N2 can detect plane polarized and unpolarized light. Hence N2 is called analyzer. Thank you.